Hi friends, welcome to TechieMit. So good to see you after a long time. So in continuation to MultiThreading series, today I have a new program on synchronized block in Java. So what is basically a synchronized block in Java? So what it conceptually means and how to really implement it. So let's see with the help of a program, and we'll have a knowledge and grasp the core concept of it. So, in response to one of the subscribers, today I will start a new trend of giving some explanation about the program, about the classes that being used. So we'll get just a primary idea that how we will build the program and what's the logic. So to start with, we are considering three classes. One is the movie counter demo. Here the logic for synchronized content that we have. So what are exactly in the movie? It will have all the synchronized block logic it will contain, and the ticket helper demo, it contains a logic for taking multiple user inputs about multiple threads for the class for logic for it. And synchronized block is the main class of the that we are in which it has the main method. So it contains the logic for thread instantiation. So yeah, so just to save your time, I have written the brief discussion how the classes will be and what are it's having. Each class is having its own principle, and so let's go a deep dive into it now. So just to save your time, I have designed a movie counter demo. Uh, the same as the previous logic. Suppose there are 500 tickets as a whole. There are total. There is an audience. There is auditorium in it, and they are having a show or a specific screen that can host 500 500 seats or size in it. So it's the ticket counter is holding all the logic. So this specific first checks the condition that number of tickets should be less than or equal to available tickets, because if the available tickets are more, uh, sorry, if the number of tickets availed are more, then simply we cannot give to the remaining users. So that condition needs to check available tickets, and it will consecutively will iterate, and it will subtract the number of available tickets. So the total headcount will go, once it's totally up, it will go down and down, 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 down. So as the number of users avail the tickets. So that's the basic logic. Yeah. So this class basically contains, and if it's none of the tickets are available, then it will go as no show, and show is houseful. Show houseful condition is there. So it's pretty much logical how it should go. So if total at the first visitor it will from the total allocation sets he may consume some of the tickets, and the total count will be deprecating deleting from 500 till let's say 495, 94, and so and so, depending on the number of tickets available by him. And once it reached the zero condition, then ultimately none of the tickets can be given. So it will simply say show is houseful. Now, the second important part is there is also one class in which we are using dependency injection, constructor based dependency injection. So inject the movie counter demo. See in the ticket helper demo, it's dependency injection used over here. That is constructor base. So basically, ticket helper demo injects a movie injects into movie counter demo class. So when a new instance will be created, automatically the movie counter demo would be injected. When a new instance for ticket helper would be created, then automatically it would dependency inject into the for the movie counter demo. So now this class TicketHelperDemo also, as it implements runnable, it must override the run method. And so as we discussed in the logic, it contains the logic for extracting the information from the user, like how many tickets do you want, and it will just give a demo information that currently which thread is executing, and upon that movie counter demo, it will uh, instance, it will invoke the ticket counter, which is a synchronized block, which is the method that is having the synchronized block, and upon the number of tickets required. Now purposely I've commented this as I wanted to give like a brief gap between the number of users as they are taking the input, so I purposely commented this also. So we need to see why this specific like sleep specific thread needs to be sleep for particular milliseconds, and what if they are not interrupted in between their execution, so what will happen. And the rest, the synchronized block, as I told, it is basically having the logic for creation of the threads, and in yes, so invoking the movie counter demo class and creation of the threads, and it will instantiate using the start method, using thread.start. Instantiate threads. Now let's compile the program and see the output. As we have seen how basically how we have developed the program, like from creating logic for individual classes and then providing the explanation, and now we'll see the console output. I will just run the program, run the Java application. See, it's currently executing thread. It is displaying, and it's displaying randomly how many tickets do you want to, like first it's displaying 2, after that it's displaying 1, 0, 3. So I give this 4, 5, 1. See what is happening. I just commented this thing thread.sleep for 3 milliseconds because it was taking the input, so it taking the input continuously. So 1, 3, 0, 2. So it's not waiting for some millisecond, because that's not the real case scenario. Because what will happen, some person like visits the counter, then he or she may take some time to avail the tickets. So for that purpose thread.sleep is necessary, because for a specific customer or like individual some time would be availed, so we need to include the thread.sleep. Right. So basically I will use 4 milliseconds for it. We'll introduce the thread.sleep over using 4 milliseconds, and it's correctly 7 and 5, that is 12, 13 tickets are available. So the head count is 487. That is perfectly fine. So out of 500, 13 tickets were available. So the head count is now 500 minus 13, that is 487. So we'll introduce these now. We'll see the difference. I'm availing 3. Okay. I waited for some time. After I value 1, I waited for some time. After that I value 2. Yeah, see, because that specific thread, it is giving input after waiting for that much milliseconds. So it's giving thread 0 is level 2, so it's encounter as 2, and only my one input is remaining now. So it waited for the some milliseconds, because while giving input, it waited for this, and after waiting for some milliseconds, it directly printed the input, because it automatically calculated for how much millisecond it should be given. So that's it. So I will reduce the time to at least for 2 seconds to keep the short for interval. I will again clear this. The guy was 2. Yeah, it's directly printing. Just for waiting for 2 milliseconds, it's directly printed the output. And again I give us 11 and suppose 3. So it's rating as 5. Yeah, so 5 and 2. Yeah, see, for waiting for 2 seconds, it give me first input immediately, and for the other threads, it's like giving by subtracting and waiting for the such milliseconds, we got the output. So for that purpose, we need to introduce sleep methods, as it's like a more practical way to like interaction between the ticket provider or the like the host or the owner of the theater. It may take some time for per individual customer, so we need to specifically introduce that delay for sleeping of threads. So this specific video was all about explaining synchronized block in Java. So how to implement it, what are the basic logic we use, and point to be noted is that we didn't make the method as synchronized, but we only make the block as synchronized. So in this method also you can have some extra logic, or that is beyond like non-synchronized context. For that you can also have the in it, so you can make the use of synchronized block when like some additional stuff you may need to include it, that can be included in using synchronized block. So stay tuned, keep liking, subscribing to #TechieMit, more to on multi-threading and other related topics, and bye for now.